Hey guys, welcome back. So, in this series of videos, I'm trying to learn risk models. So, initially, I started with the historical simulation, then I went to Delta Normal, then Monte Carlo. So, now I'm at EWMA template. It's the same data set. We're just trying to implement more and more risk frameworks. You can see earlier videos if you want to start from very basics. Okay, then if subsequent we are going to put on Garch model and various other models like filtered historical method, EVT, stressed VAR. All those things we are going to apply in this series. Okay, it's also the first time that I'm also learning. Okay, so my strategy is to learn by actually implementing it. Okay, so in this video we are going to learn about the EWMA. Okay, so EWMA is one of the most important concepts in market risk. EWMA is volatility and EWMA value at risk, both the things we are going to learn in this video. Okay, so from the name itself, EWMA stands for exponentially weighted moving average. Okay, it is one of the simplest, fastest, and widely used methods to estimate dynamic volatility. The idea is very simple, that we need to give higher weightage to recent returns, and we need to give the lower weightage to uh, older returns. Okay, so why we need it? So basically, it gives picture that today's market matters more than the markets which were 6 months ago. So basically, it is taken from the JP Morgan's risk matrix division, and we are going to use that framework here. Okay, so here is the formula of calculating EWMA variance. So here it is, if you can see. So it uses a parameter called lambda. So what is this lambda? So lambda is a decay factor, okay, which helps us to calculate the standard deviation. So after a derivation, we take a lambda. The recent volatility will be the lambda multiplied by the standard deviation of previous day plus 1 minus lambda into uh, squared return of yesterday. Okay, so we are going to implement it this, and we are going to find out EWMA variance, EWMA covariance, then portfolio variance, then we are going to calculate VAR, then we are going to calculate the expected shortfall. So these are the steps I have written here. So you can follow me of through here. Okay. So first is simple, like we in first step one is the we need to prepare the data, and yeah, I have already prepared the data. So the data is last 1 year daily closing rates of dollar INR and dollar JPY. Okay, and so this my portfolio consists of I just write down these parameter as well. Portfolio value is equal to USD 1 million. So I'm just going to, okay, so it's just USD 1 million. Then my weightage for dollar INR is 60%, and weightage for JPY will be 40%. Why it is lagging? I just need to find out. So we are going to calculate the daily returns of dollar INR. Okay. So current day closing rate minus previous day closing rate divided by previous day. Losing rate. Okay. Similarly, we can just copy paste the formula for here. My PC has become a little bit slow because of the various functions going on. So we have completed step two. So we have found out the daily returns on dollar INR and dollar JPY. So now we will be moving to step number three, calculating EWMA variance. So first we need to provide the seed value to this particularly EWMA model. So if you can say that there is a, in this formula, we can see that there is a standard deviation from the previous day. So to find out effective previous day standard deviation, we are going to take a value of at least around 20 days. For this example, I'm taking a 20-day standard deviation as a seed value. Okay, so let's calculate how many days are there. 20. Okay. So I'm going to be taking this as a seed value. VAR variance. Similarly, also going to have covariance. So we have calculated the seed value. Now we are going to calculate EWA covariance for next day. So we are going to use this formula here. It is equal to lambda. Lambda is 0.94 times variance of previous day, which is this, plus 1 minus lambda again multiply by square return of previous day. Okay. So we are just going to fix these parameters here. We can copy paste those here. Let's see if we get the same value. Cool. Then we're going to calculate the covariance again from this covariance matrix. So it's again similar. So what I can do here is mm, I can just copy paste this formula. So it involves squared return. F2, 3. I can take returns of these two values here. Okay, then I can simply just drag this formula. Okay. So we found out the EWMA. Just so we just find out the EWMA covariance for this particular date. So just EWMA variance side. So it will be equal to this value. Okay. Then again EWMA variance JPY. It will be equal to this value. Let test EWMA covariance. It will be equal to this value. Now we are going to calculate the portfolio's variance. Okay. So in this step, what will the formula here? I can just copy this formula here so that it is easier for you to understand as well. Portfolio variance equal to weightage of dollar INR, which is 0.6 into 0.6 multiplied by variance of INR plus weightage of dollar JPY 0.4 into 0.4 into variance of JPY plus 2 multiplied by weightage of dollar INR multiplied by weightage of dollar JPY multiplied by the covariance that we received. So we received this value here. We received the portfolio variance and we can easily calculate portfolio standard deviation by taking square root of portfolio variance. Now we are going to calculate the 95 percentage day VAR. Okay, so we again, if we go through our steps, VAR can be easily calculated by Z alpha, which is the Z squared value of alpha multiplied by the portfolio variance multiplied by the portfolio standard deviation multiplied by the portfolio value. I'm just copy pasting here for your reference. So how we are going to calculate it? Z alpha will be norm dot I s dot inv 1 minus, we are calculating for 95 percentage, so 0.95 multiply by portfolio standard deviation multiplied by the portfolio value, which is equal to 1 million. Okay, we received the portfolio and it will be again in dollars. Similarly, we again can calculate VAR for 99 percentage confidence interval. So it is our VAR is found here. Now we can also calculate the expected shortfall. So we have formula for expected shortfall as below. We can calculate it. Sorry, we can copy it. In this formula, it does miss the multiplication by portfolio value. So we need to take that as well. Otherwise, portfolio standard deviation multiplied by exponential minus 0.05 into 0.05 multiplied by Z value. We can do calculations easier. So that I'm telling, showing how G score is calculated. Condition into exponential minus 0.5 multiplied by C score square 2. Minus alpha. Then we are going to again take an square root 2 multiplied by pi. We're going to again multiply by portfolio value, which is 1 million. We can put expected shortfall as a minus. So we can got this expected shortfall here. So if you can say it is more than the 95% VAR. Now we are going to calculate values for this. We're going to change the G values. So we calculated 95% VAR and 99% VAR, then 95% expected shortfall, and then 95% expected shortfall. Okay. So, so you know that why it is better than the simple moving average. So basically, it is reacting faster to the volatility burst. It avoids fixed windows, shy size problems, and it is used in risk matrix. But there are some shortfall as well, which includes it cannot capture volatility clustering, it cannot generate fat tails, and there is no mean reversion here. So it is used in banks for calculating daily market risk, value at risk, stress testing, initial margin forecasting, intraday risk monitoring. Okay, so so if you seen, that's exactly how we are going to calculate how we calculate EWMA volatility and EWMA VAR in Excel. If you find this helpful, so do check out that what we are going to implement. We are going to implement Gauge in next video. So you can just follow this series, and I hope it will be useful to you. Thank you.